Hey everybody, it's Friday, St. Patrick's Day 2017, and I'm going to spend some time going over your review sheet. The reason I'm spending my time doing this is so that you spend a lot more time using it to practice to make sure that you can do these 12 different types of questions. The exam will be Thursday or Friday. Thursday for period 1, Friday for period 8. And let's see this thing on over. Number 1 has got multiple choice strategy screaming at me. When you see variables in the problem, variables in the answers, we use multiple choice strategy. So, if you still don't know how to do multiple choice strategy, watch this. And if you still don't know how to do it after that, please ask somebody. Let me get my calculator up. Make sure you have values set for x and y. I guess I'm going to go over here. So I'm going to do 10 store as x and 15 store as y. I'm picking these values arbitrarily. Can't be 0, can't be 1, 2's not great either, and x and y have to be different. So now I'm going to type in the original problem. I got parentheses. I've got a fraction, so I'm going to hit alpha y equals enter. Instead of w, I'm going to do x to the power of -5 over x to the power of -9. I'm going to get the cursor out of the fraction to the power of. I got a fraction in there as well. So again, I'm going to type alpha y equals enter. 1 over 2. I'm going to get the cursor out of there. Now I have the original problem typed in. I hit second math, which is test. I hit equals. Then I type in each answer. X to the power of x to the power of -7. If it's correct, it will give me a 1. If it's incorrect, it will give me a 0. It gives me a 0, so that's not right. I don't want to retype the whole thing, so I'm going to copy this by highlighting it and hitting enter. And instead of x to the -7, I'm going to try x squared. I get a 1. Sweet. I'm going to go through the rest of the choices to make sure that that's the only one, because in some circumstances it's possible you might get more than one 1. That's a 0, x to the 7th, and finally x to the 14th. Zero. So I got my answer. Now, if you're doing it by hand, there's a couple different ways to go about doing this. I'm going to do it in the parentheses first. When I divide exponent, I subtract the powers. So it becomes w to the -5 minus -9, which is w to the 4th. To the half power, 4 times 1/2 is 2. If f of x equals that, and g of x equals that, what's the solution to f of x equals g of x? Well, if f of x equals g of x, I'm going to set f of x equal to g of x. Ooh, there's a typo in this question. Please change the problem to that. So it should be g of x equals log base 6, x plus 9 plus 9. Minus b. Now, can you solve this algebraically? Well, I didn't teach you how to do this algebraically. I solve this algebraically. Maybe? But that's irrelevant. I can solve this graphically. I can graph that. I can graph that. And I can see where they intersect. So I'm going to go back to my calculator. I'm having so much fun. For whatever reason, when I touch the board, it's not working, so I have to come all the way over here. Use my little keypad. I'm going to go to y equals. I'm going to, oh, they're in there already? Sweet. So type them in. If you don't know how to type in log base, it's alpha window. I'll just demonstrate here. Alpha window 5 is log base, so that's how you can get that template. And the absolute value bars are 2 spots. It's alpha window 1. It's also math num EBS. So now that I have that, I'm going to start with Zoom 6. Zoom 6 is my regular standard window. I look at Zoom 6. There's my first graph. Looks like it's a little cut off. And there's my second graph. Do I see what I want to see? No, I want to see more. I need to find their intersection. It looks like I have stuff going on up top here. So if I want to see more of the up top, I'm going to go to my window. When I go to my window, again, I want to see more of the top. The top is my y max. X min is your left. X max is your right. X scale is just how much each box is worth. Y min is your min, so your bottom, and Y max is your top. So instead of 10, it can be whatever you want. Let's try 20. Let's see how that looks. I'm going to go back. Whoops, that was 2. So let's see if 2 is a good idea. 2 is an awful idea. So let's go back to window, and let's change that to 20. Let's look at this graph. Ooh, that one looks nice. And that one looks nice, and I can very clearly see my points of intersection. If it looked like they were going to intersect again, then I might need to adjust my window more. But it is very likely you're going to have to adjust your window. So now to actually calculate the intersection, I hit second, calc. Try that again. Second, trace or calc. Option 5 is intersect. I scroll to one of the intersection points. I just need to get it close. I hit enter for first curve, enter for second curve, enter for guess, and I've got negative 3.87, round to the nearest hundred. So I'm going to jot that down, negative 3.87. Now I'm going to repeat that process. I'm going to hit second, trace, intersect. I'm going to scroll over to my other intersection. I'm going to hit enter, enter, enter. To the nearest hundredth, I have 3.93. Notice I'm only writing down the x values. When I solve this equation here, I'm solving it for x. That's why I'm writing down the x values. Which is the solution? Well, what did I do wrong? Let's see, on my answer key, I had negative 3.86. Did I round this wrong? I must have, because the only answer that's there is choice 4, 3.93. Let's just go through that again. Did I round wrong? 3.93 is definitely correct. Second, trace, option 5. Enter, enter, enter. Negative 3.86, yes. So be very careful when you're rounding. Even me, Mr. Schlansky, from time to time makes a mistake. The difference between you and I, if you're not getting those right, is I'm able to catch my mistakes. Look back, make sure it makes sense, double check yourself. I'm ready to move on to number 3. The graph of P of X is shown. Here's a big, big, big concept. Big concept for this problem that they want you to know. In a graph, this is super important. These are the zeros. The zeros are 3, 0, and negative 40. So first of all, if those are zeros, then P of negative 4 is 0, P of 0 is 0, and P of 3 is 0. So if those are the zeros, you can determine the factors. If negative 4 is a 0, then x plus 4 is a factor. If 0 is a factor, then x plus 0, or just x, is a factor. And if 3 is a 0, then x minus 3 is a factor. Because if I were to set each of these equal to 0 and solve them, I'm going to get these values. If it's a factor, I also know that all factors divide into the polynomial evenly, without a remainder. So, choice one, option 1 here, negative 4, 0, and 3 are zeros. Yes. X plus 4, x, and x minus 3 are factors. Yes. P of negative 4 is 0, P of 0 is 0, P of 3 is 0. Yes. The polynomial is divisible by x plus 4, x minus 3. Yes, it's all true. So this is a great little study example for you. Once you know what the zeros are, you know that P or F or whatever, in this case, P of those values are 0. And once you know what the zeros are, you know what the factors are. And if they're factors, they divide evenly. You need to know all of those things. It's a very big concept. Blank space. 2 methods for this. When you see a 3 by 3 system, we use matrix method. X, Y, Z equals A inverse B. Matrix method when it's 3 by 3. Check out my songs on this page too. They're awesome. They're awesome. Well, they're okay. But they're helpful. Negative 1, 1, 2, 2, 3, 1, negative 3, negative 4, 1. These are the coefficients of those values there. That's A. Inverse, B, are the solutions here. 7, 1, 4. Now from here, you let your calculator do all the work. In case you still don't know how to do that, I have one student in mind who's stubborn and refuses to do this, and she gets it wrong every single time. Here's what you do. Everything is in matrix. So matrix is right here. Second matrix. I'm going to go to edit. Enter. Do I have this one in here already, or is this a different one? 3 by 3. Nope, this is a different one. So it's going to be 3 by 3. I'm going to type in the values, negative 1, 1, 2, 2, 3, 1. Then I got negative 3, negative 4, 1. Now I'm going to go to second matrix. I'm going to go to edit. I'm going to go to B. And I'm going to input my 3 by 1. I got 7. I got 1. I got 4. Now I'm going to get out of here. I'm going to hit second, quit. Now that I have that, I type in A in the matrix menu. Inverse, which is the same button, but without the second. Then I'm going to go to second matrix, B. If I did everything correctly, I should get a nice answer that looks nice. If you get really, really long decimals, most likely you type something in wrong. And I got negative 2, 1, 2. So, x equals negative 2, y equals 1, z equals 2. You do it a couple times. It's simple. It's one of the easier types of questions for us to do. So make sure you get it right. Let's change it up. Let's go green for St. Patrick's Day. Given the function, state the. I like to do my little graph. I make 3 lines, a max, a min, a midline. Whenever I'm dealing with sine and cosine graphs, it's always amp, sine, freak, x, shift. Okay, that's all recorded for you too, one of my favorites. So, as far as my little picture over here is concerned, the shift is the midline, is 1. The amp is 4, so that means I'm going 4 up and 4 down. 1 plus 4 is 5. 1 minus 4 is negative 3. It's a negative cosine, so it's going to start at the bottom, go up, and come back down. You need to know your 4 different graphs. Positive, negative sign, positive, negative cosine. So, that gives me a lot. Then my domain for all trig functions is always all real numbers, or negative infinity, positive infinity. My range, well, my min is negative 3, my max is 5, so my range goes from negative 3 to 5. My minimum is negative 3, my maximum is 5. Seems pretty repetitive. My midline is y equals 1. My amplitude is 4. Now, frequency is what's in front of the x, or in this case, the t. My frequency is pi over 3. Now, my period, you need to know this little formula is 2 pi over the frequency. I'm going to erase my little picture at this point. I got everything I need from it. Look at the 3 back there. Hope you're not missing it too much. There it is. So the period is 2 pi over 3, and you're not afraid of dividing by a fraction because you know you keep, change, flip, or multiply by the reciprocal. Pi's cancel. 2 times 3 is. So the period is. What is the significance of pi in the equation? Well, what's in the parentheses is a horizontal shift. So it's a horizontal shift. Pi units to the, you know what direction that's moving? I do. It's the left. And you can review your translations rules if you're a little sketchy on that. Sketchy, it's funny because, you know, we're sketching. Okay. Number 6. Given f of x equals and g of x equals, state the quotient and remainder of f of x over g of x. So I'm dividing f of x by g of x. Got a song for this too. Divide, multiply, subtract, bring down. Divide, multiply, subtract, bring down. And to subtract, we keep, change. A cycle goes through this process. You divide, you multiply, subtract, bring down. That's a cycle. So I'm dividing the first by the first. 4x to the third divided by x is 4x squared. I put the x squared over the x squared here to keep it organized. Multiply. Multiply the 4x squared times x plus 3. That's 4x to the third plus 12x squared. Subtract. To subtract, I keep, change, change. That gives me negative 10x squared minus 5x. That's your bring down. That's a cycle. Let's go back to our St. Patty's Day green. Now again, I divide. I divide the negative 10x squared by the x. That's minus 10x. Multiply negative 10x squared minus 30x. Subtract, keep, change, change. 25x, bring down, plus 1. Next cycle, 25x divided by x is plus 25. Multiply 25x plus 75. Subtract, keep, change, change. Cancel. I got negative 74. Is that what I got when I did it here? Yes. So, my quotient is 4x squared minus 10x plus 25. And then I have to put my remainder over the divisor. That's what this is saying. I'm afraid that people are going to be scared by that. You know that. You're just not used to seeing that weird math terminology. That is your answer. Know how to divide polynomials? You get it right. One of those skills you got to be able to do. All right, got another trig function here. I got my amp, sine, freq, and shift. This is very similar to the problem we just went over, because this is more of a real-life type situation. Let's do my little picture. My midline, my shift is 80. My amp is 70. So this is 80 plus 70, which is 150. 80 minus 70, which is 10. It's positive sign, so it starts in the middle, it ends in the middle, middle, goes up first and down. Here's my little picture. What is the minimum and maximum height of the cars in the Ferris wheel? Well, my min is 10 feet and 150. What is the diameter of the Ferris wheel? Well, the Ferris wheel is going like this. If its lowest point is 10 and its highest point is 150, the distance from 10 to 150 is 140 feet. If it's a Ferris wheel, the diameter is the distance from the maximum. How long does it take for the Ferris wheel to make one complete rotation? That is asking for the period. It doesn't tell me the period, but it does tell me the frequency. And again, the period is 2 pi over the frequency. Based on amp sine freq x shift, the freq is in front of the variable. The frequency is 2 pi over 7. So my period is 2 pi over 2 pi over 7. So that's going to become 2 pi over 1 times 7 over 2 pi. 2 pi cancel. 7 what? 7 what? 7 minutes. To go back and forth between period and frequency, we just use the formula period equals 2 pi over the frequency. The rest of it, as long as you know amp sine freq x shift and you draw your little picture, you know what your 4 waves look like, you should be good. What do we got next? The following table shows the number of points the Arlington girls team scored in their last basketball game, where T is the time passed in minutes and F of T is the total number of points scored for T minutes. Fantastic. What is the average rate? Average rate of change. Yeah. Average rate of change. Average rate of F of B minus F of A over B minus A. If you know your formula, if you know your song, this is easy. Now, the only little twist, the first half of the game, well, the first half of the game is from time 0 to time 16. So F of B and F of A is 48 minus 0. B minus A is 16 minus 0. You can use the calculator to do this. You can use your mathematical abilities. 3 what? This is 48 points over 16 minutes. So it's 3 points per minute. It's a good idea to use units. What was our average rate over the whole game? Well, let's go back to St. Tidy's Big Green for that. That's from the beginning to the end. That's going to be 64 minus 0 over 32 minus 0. 64 over 32 points over minute is 2 points per minute. Does it matter if the x's or y's go on top? Yes. The top is f of b minus f of a. Your y values go on top. This formula, of course, is based off the slope. C, given your answers above, which half of the game do you feel had a better rate of scoring? Well, if they had 3 points per minute in the first half, for the whole game, it was 2 points. It obviously went down, so they scored better the first half. Because the average rate dropped. You get an average rate of change question wrong, you made some bad choices somewhere along the way. On the set of axes below, graph one cycle of a cosine function with an amplitude of 3, period pi over 2, midline y equals -1, passing through 0, 2. Let's get my little picture, and let's get my amp sign free kick shift. Doesn't matter which one we do first. Let's do the sketch first. First of all, pass to the point 0, 2. I'm going to get that on my graph. It has an amplitude of 3. So let's get that here. It's cosine. Now, is it positive or negative cosine? Well, if the midline is at -1 and it passes through 0, 2, then this must be the max, since it's above the midline. So the max is going to be 2, which means the amp is going to be 3, which it says anyway, which means the min is going to be -4. Now, because it's starting above the midline, it's going to be a negative cosine. It's going to be a positive cosine. 3. Well, it's not telling me the freak, it's telling me the period. So I can do frequency equals 2 pi over the period. The formula works both ways. So it's 2 pi over 2, which is 2 pi over 1 times 2 over pi, which is 4. I need the frequency for the equation. I need the period for the graph. So because this is 0, I know that the wave is going to end at pi over 2. So I know it started at the top, it ends at the top. So let's something like that. Shift. Shift is my midline, which is -1. So let's do the graph first. I like to always make 1, 2, 3, 4 ticks, since it's going to always be 5 points on a wave. 0, and then the 4 other ones. You can choose to call this whatever you want. I'm going to make pi over 2 the last one, so I'm just making 1 full wave over here. It starts at the top, it ends at the top. In the middle, it is 3 below the midline, since the amplitude is 3, and the in-betweens are on the midline. It's asking for 1 full cycle. There's 1 full cycle. So when it comes to other values, this is half of pi over 2, which is pi over 4, and half of pi over 4 is pi over 8, which makes this 3 pi over 8. That's not as necessary. As far as my y values go, I made each box worth 1, so you can give me 1 or 2 values. That's fine. The equation, well, I have all the information written in this region right here for that. Y equals amp cosine freak x shift. Spent a lot of time in the trig graphs. Came to school, did your work, should be good on that. Your favorite, the Ferris wheel. A carnival is a Ferris wheel that is 50 feet in diameter with 12 passenger cars. All right, so I got 50 feet diameter. So from here to here, it's got to be 50. I'm going to start making my little picture over here. And as you can see, you can put into the picture, if the diameter is 50, the radius is 25. When viewed from the side where passengers board, the Ferris wheel rotates counterclockwise and makes 2 full turns each minute. Well, if it makes 2 full turns each minute, that means the period, 1 full turn, must be 30 seconds. Riders board the Ferris wheel from a platform that is 40 feet above the ground. So this is my platform right here. This is 40 feet above the ground. So from here to the ground is 40 feet. Now, because from here to here is 25, I think I froze. All right, I just unfroze. Let's see if this works. Because this is 25, the distance from here to the bottom must be 40 minus 25, which is 15. So, at this point, I have my midline must be 40. My amp must be 25, which makes this 65 and this 15. Create a graph for car 1. So car 1, it's starting at the midline. It's then going counterclockwise, which is getting bigger. So if it's starting at the midline and then it's getting bigger first, it must be a positive sign graph. As far as my x value goes, this is 0, the period is 30. So it's time to graph. So let's see if I can do this here. Let's see if I can take my little picture and copy it here. Oh yeah, that was great. So, how much is each box going to be worth? Well, I'm going to start with 0. I'm going to make, again, 4 ticks. 1, 2, 3, 4. The period is 30, so I put that here. I cut that in half for the middle here. Half of 30 is 15. What's halfway between 0 and 15? Well, it's not a perfect number. It's 7.5. You don't have to put that value in. So if each tick is 7.5, then this one must be 22.5. X-axis is done. Y-axis, it's got to go up to 65. So I'm thinking making the mathematical way to do it. You can divide it by the number of boxes, which in this case is 17. It's got to be something bigger than that. 65 divided by 17 is 3.82. So I said I'd pick something that's bigger than 3.82. Makes sense. I'm going to make each box worth 5. You don't have to use 5, but it's got to be something bigger than 3.82. So I'm going to just label every other box to keep it a little bit neater. 10, 20, 30, 40, 50, 60, 70, 80. I'm going to graph my midline. My midline is 40. It's assigned, so it starts at the midline. It ends, so at 30, it's at my midline. In the middle, at 15, it's at the midline. It goes up first, so it's going up to, we said 65, and then it goes down to 15. That's 10, that's not 15. 15 is right here. I draw my curve. If I want to write the equation of this thing, amp sine freak X shift. Does it tell me to use any specific variables? No. I don't even know if it asked me to write an equation. I'm going to write one anyway. Y equals, the amp is 25. Its sine. The freak is, oh, we didn't find the freak yet. So let's find the freak. The frequency is 2 pi over the period. The period is 30. So if I reduce that, I get pi over 15. X plus the shift is. It feels like we should be done at this point. But we're not. Number 11. That's not number 11. That's our break time. Is the graph below represented by arithmetic or geometric? Well, this thing is definitely exponential. So since it's exponential, I know it's got to be geometric. So geometric, because the graph is exponential. You could say because the pattern is multiplication, I'm multiplying by a constant amount, there's a common ratio, whatever. What is a recursive function that can be used to represent this situation? Recursive, great, I know my song. Recursive A1 equals AN equals AN minus 1. All I have to fill in is what A1 is. A1 is 2. And what the pattern is. 2, 6, 18, 54, 162. I'm multiplying by 3. So since I'm multiplying by, I put it in front. That's my recursive function. You get a recursive function wrong, you just don't know your song. You just don't know how to write it. And I am not very happy with you because it's just simple. Explicit's even easier. It's on the reference sheet. Actually, it's not even easier. They're both really, really simple as long as you know the formulas. On the reference sheet, AN equals A1, R to the n minus 1. A1, again, is 2. R is 3 to the n minus 1. The only time this changes is if it's A0 instead of A1, in which case you'll lose the minus 1. And I believe we have just one more. Lindsay's parents have $3,725 they want to invest for her while she's in high school. Good. Fantastic. They will keep the money in the account for the 4 years while Lindsay's in high school. Fantastic. They are deciding between 2 different banks for their investment. Good idea. Seattle Mutual offers a 1.6% interest rate that is compounded weekly. Compounded. Principal parentheses 1 plus minus r over n to the power n t. Compounding for continuous. When I see compounding, I use this formula. If I see compounded continuously, which I'm going to see in the next sentence, then I use a slightly different formula, which is PE to the power of RT. All right, let's fill in my values. In both cases, let's start with Seattle Mutual. Don't know if some of you are picking up on that there, so I'm going to do S of T. The principal is $37.25. It's interest, so it's plus. The rate, you must divide that 1.6 by 100. So it becomes 0.016 over n. It is being compounded weekly. N is 52. To the power, n is 52. T is 4 years. What do you think I'm going to do now? I'm just going to let the calculator do it for me. So let's do that. I've got my 37.25 I've got parentheses. I've got 1 plus alpha y equals. Enter. 0.016 over 52. Get out of the fraction per exponent 52 4. Enter. In general, we want to round to the nearest cent unless it specifies otherwise. What scares me is that you guys still don't know how to round to the nearest cent. I guess you never bought anything from the store. When you go to the store, you have 2 decimal places that appears in the cash register, 39.7116. Now let's go back to my St. Patty's Day green. A equals, not A equals, this one's going to be TB Bank South, so let's call it T of T equals 3725 e to the 0.0157 times 4. Again, I'm making that rate into a decimal. I divided by 100. And let's pull up my calculator again. And let's do 3725. If you still don't know where E is, then you've probably never done a weekly review ever. And you probably don't have a grade that's very high right now. It's in 2 places. It's above ln and it's above division. Because I have an exponent attached to it, I'm going to do the second ln, so that can save me, like a third of a second instead of having to hit the other button. 0.0157 times 4. $39.66.43. Again, 2 decimal places unless it says otherwise. 39.66.43. So I don't know about you, but I want more money than less money, so I'm going to probably go with the Seattle Mutual here, because it's more money. And it says how much more money would they earn. So to determine that, I'm just going to subtract them. 39.71, what was that, 16? 66? What am I looking at? 39.71.16 minus 39.66.43. We've used the calculator a lot today. Let's see if I can actually do some real subtraction here. 6 minus 3 is 3. That's 7. That's 4. And that's 0, 0, 0. $4.73. Might not sound like a lot of money, but I don't know. You can get like 3 10-piece nuggets at Burger King for that. So that's a lot of chicken. That's all I got for you. Use this. I can check to see how many hours this thing was viewed. I'm not going to be happy if it's not many. This is a great resource for you guys to not only use this to prepare for your exam, but also use this in the future when you're preparing for your Regents exam. Okay, you're still going to be responsible for these types of questions, so utilize this. I hope you had a great time utilizing this, and now you should probably, take a break and then do it again real soon. Real soon. I'm forgetting how to close this thing. 44 minutes. See you.